All right, we're going to start by grading 10-1. It's out of 39 points. It must be graded in red, so please have it in red. You will show me your score the next time I see you in class. I will also be looking at what you have submitted in Google Classroom, and it should be consistent with what you're scoring on your paper. So the first one, we start with our given 4.37 times 10 to the 27th molecules, and I convert that to moles by using Avogadro's number in the denominator. My final answer is 7.21 times 10 to the third moles of H2, or I could have it in standard form, 7,210 moles of H2. You don't need both answers, but let's say you just have 721. It's minus a half for the answer. And in the box where it says here A/R, you would put a half point in there. If you're marking off your sig figs, let's say, for example, you left all your digits, it's minus a half for sig figs, put minus 0.5 where it says SF. Let's say you forgot moles, minus a half for unit, substance is H2. If you forgot the substance or you have the wrong one, it's minus a half. Moving on to 2, you take 4.5 moles and it says how many representative particles? Okay, NaCl is sodium chloride. Sodium chloride is a formula unit. So you must have formula unit here. If you don't have formula unit here, it's minus a half. Avogadro's number is in the numerator. The answer is 2.7 times 10 to the 24th formula units of NaCl. What if you forgot the power of 10? It's minus 0.5 for the answer. If you left 3 sig figs, it's minus a half, and you would put a half for where it says sig figs. The substance is NaCl. The unit is formula units. So if you accidentally put molecules, it's minus a half where it says unit. The next one, you're looking at molecules, and you're going from molecules to moles. When you take 2.7 times 10 to the 26 divided by 6.02 times 10 to the 23 molecules, you get 4.5 times 10 to the second moles of H2O. Or you could have it in standard form, 450 moles of H2O. Make sure that if you don't have your power of 10, it's minus a half for the answer. Sig figs are half, unit half, substance half. For the next one, we're looking at number 4. You're going from moles of carbon to carbon. Representative particle would be atoms. You can't just have representative particles. You know the formulas. You know what the formulas mean. You got to make sure that you include the type of particle. So this would be atoms. 4.36 times 10 to the 25th atoms of carbon. If you forgot your power of 10, it's minus a half for the answer. 5. A lot of students think that 5 looks just like 6, and it kind of does, just the first step. So you take 13 moles of H2 times 6.02 times 10 to the 23rd molecules of H2, and you get 7.8 times 10 to the 24th molecules of H2. Make sure that you have your power of 10. What if you're getting the wrong power of 10, like times 10 to the 25th or times 10 to the 23rd? You're probably not using your calculator correctly. It's important that you go back and make sure that you're using the E button, not the times or the 10. We'll do some problems later in the video. You should make sure that you're putting them in your calculator as we are going through them in notes. Make sure you write how many you missed at the bottom of page 1 on the front. Moving on now to page 2, the back of 10-1. How many atoms are in 13 moles of H2? You could have continued the answer that you had for 5 and then used this step here, but if you didn't, it should be a 2-step problem. You start with your given of 13 moles of H2 multiplied by Avogadro's number to get particles. But this is asking for atoms, and right now you have a molecule. So if we had our molecule kit, it's almost like you had a bond with 2 H's connected to each other, and we want now to count the atoms. So then there's 2 atoms of H for every 1 molecule of H2, so that's 1.6 times 10 to the 25th atoms of H. If you have H2 for the substance, it's minus a half. 7, you're looking at Al2O3, which would be formula units, and you're going from atoms of Al. You're going from 1 formula unit to atoms of Al. When I look at the formula of Al2O3, there's 2 atoms of Al for every 1 formula unit of Al2O3. So you multiply, don't forget your power of 10. 4.86 times 10 to the 24th atoms of Al. Next one is number 8. 8 I like because you have P2O5, which means it's 2 nonmetals. It's a molecule. So you're going to use Avogadro's number with the molecule. And then you have to go to atoms of P. If this number here after the P was a 6, you would put a 6 here. But because there's a 2 here, you put 2 atoms of P. And then the answer is 2.82 times 10 to the 25th atoms of P. Number 9 we did together, except for the answer. So let's look at the answer, 1.13 times 10 to the 25th atoms of O. Make sure you have your power of 10 to 25. The last one, you are looking at determine the number of atoms of copper in 7.12 moles of copper 2 chloride. So you take your 7.12, you're going to use the same conversion factor as a previous problem, but now you have one formula unit of CuCl2, and there's only one atom of Cu in CuCl2. So then your answer is 4.29 times 10 to the 24th atoms of Cu. You should have a score out of 39 points. Now we're going to move on to the notes. We are on page 3 of the notes. You will need a calculator, your pink periodic table, something to write with, and then maybe a different color so that you can note your sig figs. So we are looking at molar mass today. When it comes to molar mass is going to be very helpful when we look at our stoichiometry island diagram. So moles are really nice to deal with because that's what coefficients are going to represent when we have balanced equations. But the reality is that we don't look at particles. We have to know how to do particle calculations, but when I have a chemical, most likely I'm going to use a balance. And when I use that balance, I'm going to have my unit in grams. And so when I mass out a chemical, it's going to be in mass. So this is probably the most, important one when it comes to the application of quantifying certain chemicals. So we need to learn about molar mass. In molar mass, molar mass is a term used to refer to the mass in grams of 1 mole of a substance. Remember, in this chapter, 1 goes with the mole. So, once again, I have my stoichiometry island diagram, and 1 goes with the mole. The unit for molar mass is grams per mole. Molar mass is the mass, which would be in units of grams, for every 1 mole of a substance. I would know this for the test. Okay? So if I want to look at atoms, it is a mass of 1 mole of any atom is going to be the same as the average atomic mass in grams. So remember, average atomic mass is on my periodic table. It's this last number here. What we're going to do, though, the periodic table is already rounded to molar masses, rounded to the 10th place, which is 0.1. If I have a compound, the mass of 1 mole of a compound is the sum of the individual masses of each atom added up together. So we're going to practice. First, I have gold. Gold, is on my periodic table. Au. So Au is my formula. Not a diatomic because metals can never be a diatomic. So now what I do is, it's only talking about gold, so there's only one of them. So Au, 1 atom, And now I look at what is the actual average atomic mass. So for Au, remember the average atomic mass is the number in the bottom of the cell for each element. So I have 197.0. So I take 197.0. And when I do that, that 0 is important. That 0 is significant. You have to write that 0. Students every year struggle with that 0. You have to include it. That is significant. We just said that it goes to the 10th, so you got to make sure you include it. All right? So now, what is my answer? 197.0. And you might say, well, what about that 1? That 1 is unlimited. Okay? And we're going to look at molar mass as adding, so we will always round to the 10th place. So we'll do practice problems, though, so that you can see. We already said that when I'm calculating molar mass, when I calculate molar mass, my unit will be grams per mole. Then I have to include the substance. What's the substance? AU. And that's it. But now, what about bromine, right? Well, I have to be careful. Diatomics, right? I have to be careful with diatomics. I got to know my diatomics. On the test, some of you didn't recognize some of your diatomics, and that's going to cost you points, right? So bromine ends in GEN or INE. So it's not just Br, it's Br subscript 2. So now bromine, I'm going to take 2 times the value of Br, which is 79.9. So I put 79.9 here. When I put this in my calculator, I have 2 times 79.9. I have 159.8. Does that round into one decimal place? Yes. So then now my unit is going to be grams per mole, because that is the unit for when I'm calculating molar mass of the substance Br subscript 2. Now we do the next one, copper 2 phosphate. So I need to look, right, at my ion list, and unless I know what phosphate is, right? And so phosphate is PO43 minus. And I know that this is an ionic compound because there's a Roman numeral there. So copper, Roman numeral 2 is Cu2 plus, and phosphate is PO43 minus. I have my ions. I'm going to reduce crisscross, and I end up with, so once again, ionic compound. I'm going to end up with Cu, PO4, cross 2 here, and a 3 here. And that's my formula. So now, when I figure out this formula, and its molar mass, you have to make sure that you distribute this 2 to the P and the O, but not the 3. The 3 pertains to the Cu. Okay? So Cu, there's 3 of them. Phosphorus, 2 of them. Oxygen, 8 of them. Now what we're going to do is look at our periodic table. Cu, 63.5. Phosphorus, 31.0. I must include that 0.0. Don't forget that. You have to include that. That is a significant digit. I need it. Make sure you have it. Then oxygen is 16.0. So I go ahead and now include 16.0. Find the answers to those. 190.5. This one here is 62.0. And notice I put that 0. That 0 is significant. I'm going to make sure that I include it. And then I have here 128.0. Once again, my calculator might give me 128, but I have to keep 1 decimal place. So if I don't have a digit there, I put a 0. So when I add those up, I get 380.5 grams per mole of the substance Cu3PO4 2. Moving on to the next one, dihydrogen monoxide. I recognize right away that I have prefixes. So when I have a prefix, right, it's a molecule. And when I have a molecule, I interpret the prefix. Di means 2, so it's H, hydrogen, 2, monoxide. O would be 1. We know that that's water. So I go ahead and figure out how many H's and how many O's I have. H I have 2 times the value is 1.0. So I get 2.0. Once again, that 0 is significant. I can't forget about it. I have to have a digit in the tens place, even if it's a 0. Same thing with oxygen. That is O, 16.0. Once again, keep that 0. That's significant. So when I look at leftmost uncertainty, right, I have to keep that 0. So 2 plus 16 is 18 in my calculator, but these zeros are significant. I got to keep that, right? So my final answer is 18.0 grams per mole of H2O. So now, why are we finding these values? Because I just found the molar mass of water. It's 18.0 grams per mole of H2O. But what does that really mean? 18.0 goes with the grams. So if 18.0 goes with the grams, 18.0 goes with the grams in a conversion factor. And the other one is 1 goes with the mole. All right? So now we're going to do our first problem using molar mass as a conversion factor. How many moles are in 242 grams of water? All right, so I'm going to start with 242 grams of water, 242 grams of H2O. And I want to find moles. So I'm going to put over here moles of H2O. Now, I'm going to use my stoichiometry island diagram just to reinforce how I'm going through these problems. Grams is a unit of mass, and I want to go to moles. So this is how I know that it's just one step. It is one step because I go from mass to moles. And so now what I have to do, right, it says 1 goes with the mole, and I have to set that equal to the molar mass, which is the grams on the periodic table. So I want to cancel out grams of H2O. So I put grams of H2O down here. What I do want on top are moles of H2O. So I'm going to put moles of H2O up here. We said in this chapter, right, 1 goes with the mole. 1 goes with the mole. So here, 1 goes with the mole. What goes with grams of H2O? Says here, molar mass on the periodic table. So I'd have to add 2 H's, 1 O. Well, look, we already did that here. That's 18.0. So then now, I put this in my calculator. So I'm going to take 242 times 1, which you know is the same answer, divided by 18.0. And I get 13.4 repeating. So I'm just going to put a few 4s there, right? But I can check my sig figs. So this is 1, 2, 3, 3 sig figs, right? This is 1, 2, 3, 3 sig figs. So I'm going to have 3 sig figs. 1, 2, 3, look to the neighbor. My final answer is 13.4 moles of H2O. All right, let's do the next one. What is the mass of 3.77 moles of gold? Anytime I ask you for the mass, it's definitely going to be in grams, all right? We don't use pounds. That's an English unit, right? We're talking about using grams because that's what we use in the lab. So now, what is the mass of 3.77 moles of gold? Well, I got to know what gold is. Luckily, I've already used gold. Gold is this one up here, AU. So I know that gold is AU. And I want the mass. I want mass. But they gave me moles. So I'm going to start here. So once again, after the given, it's just a one-step problem because I have to go from moles to mass. You don't want to memorize like what goes in the numerator, what goes in the denominator. What you want to know is what conversion factor you have to use. In this case, we're using molar mass to get to mass, all right? So now I'm going to start with my given. So I have 3.77 moles of AU. And I want grams of AU, so I'm going to put grams of AU over here. And I want to cancel out moles of AU. Once again, I want to go from moles to grams. To go from moles to grams, 1 goes with the mole. Molar mass grams on PT means periodic table goes with the grams. So 1 goes with the mole. Grams AU, well, what's the number on the periodic table? We already found it up here, but what if we hadn't found it yet? I would go here, AU is 197.0, so I put 197.0. Now, you have to put that 0.0 there, just like this one here, 18.0. That is important. All molar masses have to go to 1 decimal place, so I want to make sure you understand that. Every year, there's students that just put 18, 197. You can't do that. You have to have at least 1 digit in the tenths place. So now I put this in my calculator. I take 3.77. So I take 3.77 times 197.0. And that gives me 742.69. So 742.69 grams. But I'm going to count my sig figs, right? So that's 3 sig figs, 1, 2, 3, 4 sig figs, least amount, 3 sig figs, 1, 2, 3, look at the neighbor. So I'm going to round to 743 grams of AU. All right, last one before we look at the homework. How many water molecules are in 242 grams of H2O? So I'm going to start with my given. That's dimensional analysis. I'm starting with 242 grams of H2O. And I want to go to water molecules. So in the end, I'm going to have molecules of H2O. So I'm going to use my stoichiometry island diagram. But I'm starting at grams, and I want to go to molecules. So I'm at mass, and I want to go to particles because that's what molecules are. So what you should understand by looking at this stoichiometry island diagram is that I have to go from mass to moles first. That's 1 step. And then from moles to particles, that's Avogadro's number. That's 2. So I have 2 steps in this problem. So the first thing I want to do, right, is go from grams. We said grams mass to moles. Moles. Why is grams on the bottom? Because they have to cancel. Remember, dimensional analysis. And this is of H2O. H2O. All right, we know that 1 goes with the mole. Let's say I get confused. I don't know what goes with grams. I'm going to look here. Grams is the number on the periodic table. Well, I don't have H2O on the periodic table, but I have H's and I have O's. I've already figured it out. It's 18.0. So now I'm going to put 18.0 here. But I'm still not done. I need molecules. So according to my stoichiometry island diagram, I got to go from moles to molecules, where 1 goes with the mole and Avogadro's number goes with particles of molecules. So I'm going to cancel out moles of H2O by putting that down here. And I'm going to put the particles, molecules of H2O up here. Remember, 1 goes with the mole in this chapter, 1 goes here. The other number, let's say I get confused, is Avogadro's number, 6.02 times 10 to the 23rd. Okay, so here's where it's important for you to practice. So make sure you have your calculator out. So you take, right, 242. And then I multiply by everything on top. Times 1 is the same number. Times, how do I put that 6.02 in my calculator? So you can see my screen, 6.02 and then I'm going to use the second, and then the button above the 7. I don't put the times, I don't put the 10, 23. Now I get an answer, and I still have to divide that by 18.0 because 18.0 is in the denominator. So now I get an answer. My answer is 8.093555, a bunch of them, times 10 to the 24th. You can't forget your power of 10, right? But now I have to count my sig figs. 1, 2, 3, 3 sig figs. 1, 2, 3, 3 sig figs. 1, 2, 3, 3 sig figs. I'm going to round to 3 sig figs. 1, 2, 3, look to the neighbor. My final answer is 8.09 times 10 to the 24th molecules of H2O. And that's my answer. All right, so now what we're going to do is look at the homework. The homework is 10-2. We're going to do this one together. We're going to do ammonium phosphate. Ammonium phosphate, I'm going to go ahead and find what is the amount of each atom that I have. So I have N, I have H, I have P, and I have O. Remember, I have to distribute. So the 3 goes with the 1N, right? So that's 3. The 3 also goes with the 4 for the H. So 4 times 3 is 12. Phosphorus is 1. And oxygen is 4. So now I look at my periodic table and I find these values. So I have here nitrogen, which is 14.0. Hydrogen, 1.0. Phosphorus, right here, 31.0. And oxygen is 16.0. Remember, you have to have one decimal place number in the 10th spot. So now I'm going to figure out what these values are. 14 times 3 is 42.0. 12 times 1 is 12.0. 1 times 31 is 31.0. And then my 4 times my 16 is going to give me 64.0. Now, I add these up. So I'm going to take 42 plus 12 plus 31 plus 64. And I get 149 in my calculator. But remember, these all are significant, so I got to go to one decimal place. So it's 149.0. This is finding molar mass. When I find molar mass, the units are grams per mole. Now, I want to talk about something. In the notes, this is where students get confused. If I ask you for molar mass, I want you to have units of grams per mole, just like this, right? But when you're doing the problem and using it as a conversion factor, this is the grams per mole. You can't put gram/mole and then put mole in the numerator. You're using it as a conversion factor. So there's only one unit in the denominator, one unit in the numerator. Okay? So then don't forget to add your substance, NH4, 3, PO4. Right? And you may ask, well, how did I get this formula, right? Ammonium is NH4, 1 plus. Phosphate is PO4, 3 minus. And so you have to reduce crisscross. It's an ionic compound. We have done one together on the front, so you know what I expect for work, right? And you know the unit and that you have to include the substance. Make sure that if one of the columns is empty, that you fill it in. I would strongly encourage you to use your ion list. I had a lot of people mess up hydroxide recently. Look it up on your list so that you can get the right answer. You also have to do the back, but I want to talk about one on the back. What is the mass in grams of 5.67 times 10 to the 24th bromine molecules? So it says, what is the mass in grams? So I'm trying to find grams of bromine. Okay, we have to know our diatomics at this point. INE means that it's a diatomic, so it's Br2, not just Br. All right, and I'm going to start with 5.67 times 10 to the 24th molecules of Br2. And I want grams. So let's say, right, I'm really confused. I'm not sure. I'm going to use my stoichiometry island diagram. So then here, I go to my particles, which are molecules. I need to go from molecules to mass. So I have to go from molecules to moles first, then from moles to mass. I can't just jump from here to here. I have to use these conversion factors. So I'm going to go from molecules to moles first. And I know that this is 2 steps, right? So I'm going to do molecules of Br2 to moles of Br2. And let's say I get confused, right? We know that 1 always goes with the mole. What goes with particles? Avogadro's number, 6.02 times 10 to the 23rd. And then molecules of Br2 cancel. I don't want moles of Br2, I want grams of Br2. So I'm going to put mole of Br2 down here, gram of Br2 up here. And this is where students still start to struggle with, what does this mean? Well, right, if I had Br2, and I know that these are hydrogens, right? But if I had Br2, these 2 would be green, right? I can't just count 1 of these, I have to count 2 of these. So Br, right, has a mass of 79.9. So if this is 79.9 and this is 79.9, together, right, they're going to give us a total of 159.8. Because there's 2 of them. And we actually found that in the notes, right? So now I'm going to let you put that in your calculator, count your sig figs, make sure you get the right final answer. Guaranteed you're going to see something like this on the test, so make sure you're familiar with that. For this assignment, make sure you upload it if you're supposed to, or have it for class to grade. You should look at your daily agenda to see exactly how you need to turn it in.